In this video, we are going to introduce a new set of numbers, the set of complex numbers. Before we do that, let me remind you how we introduced new numbers before. For example, when we considered the equation x squared equals 2 and realized that it has no rational number solution, so there is no ratio of integers which can be squared to get the number 2. In a similar way, when we look at the equation x squared equals -1, we can quickly convince ourselves that there is no real number solving this equation, because if you square a positive real number, you get a positive real number. If you square a negative real number, you still get a positive real number, and if you square 0, you get 0. So there is no real solution of this equation, but introducing such a new number, which would square to -1, leads us to a whole new set of numbers which have all sorts of nice properties and make mathematics really beautiful. So let me start with the definition of a complex number. So definition: a complex number Z is a number of the following form: Z equals x plus yi. So it has a form of a sum where x and y are real numbers, are elements in the set of real numbers, and y squares to is a number which squares to -1. So it's a solution of this equation. We call this new number I the imaginary unit. Okay, so this is the definition of complex numbers. It's a sum of a real number and a real number multiplying this imaginary unit, this new type of number, which squares to -1. Okay, let me give you a few more names. So x and y, they are very important. They have their own names. So x is the real part of z. It's called the real part of our complex number z, and y, the real number y, is the imaginary part of z. Okay, and we have some special notation for these two notions. So we say that the real part of z, Re of z, is equal to x, and the imaginary part Im of z is equal to y. Okay, so let me make a few remarks at this point. So remarks. My first remark is something for you to notice. If I look at a complex number and set its imaginary part to be 0, I will get a real number. So it means that the set of real numbers sits inside the set of complex numbers. So R is a subset of C. This is the set of complex numbers. Let me just make that clear. The set of complex numbers okay, so C stands for this set of numbers of this form, x plus yi with x and y being real numbers. Okay, my next remark is when we do the opposite, we set x to be 0, the real part to be 0, then we get a number of this form, z equals y times I. So if x is 0, then z is equal to y times I, and it's called a purely imaginary number. Okay, and my final remark is just something to be aware of, is that engineers use a different letter. They use J instead of I for the imaginary unit. So engineers use J instead of I. So if you open a book on engineering, you might notice that it's full of J's where it's supposed to be I. Okay, finally, there is a very important notion, a very important partner for each complex number, and that is its complex conjugate. So it's a definition I want to introduce. Okay, so the definition is the complex conjugate of z, if it's given in this form x plus yi, then its complex conjugate is denoted by z bar, and it is equal to x minus yi. So you can see that the imaginary part has its sign flipped, and that is how you get the complex conjugate of a complex number. Okay, so before we finish, let me ask you a question, and you should pause the video and answer it below. So let me just make some room for this. So let's consider the number z equals 1 plus 2i, and what I would like you to give me is the imaginary part of z divided by the real part of z. Okay, what is this number? I will give you 4 options. Option A is 2 over 1. Option B is 1 over 2. Option C is 1 squared plus 2 squared. And finally, option D is 2i over 1. Okay, pause the video and select the correct answer below. All right, I hope you paused it. So the correct answer, well, I'm not going to give it away just yet. I'll instead make a note of a common error that people make. So you might have chosen D, but that is incorrect, because the imaginary part of a number, of a complex number, is the real number that multiplies I, not the entire expression, entire term here, just that real number y. So in our case, the imaginary part of z is plus 2. So let me try to indicate that. So plus 2 is the imaginary part of z. Okay, so it's not 2i over 1. The real part of z is of course plus 1, but the point is that the imaginary part is this plus 2. So the correct answer is not C, nor it is answer B, but option A. Okay, I'll see you in the next one.